Alright, so this video we're going to take a look at exponential functions and their applications. Alright, so let's go ahead and get started. We've got quite a bit to cover in this video. So an exponential function with base a is a function of the form f of x equals a raised to the x. The a here, this is your base, and this is your exponent. All right, and then it says where x is any real number and a is a real constant such that a is positive. That's what this means. A is greater than 0, but it's not equal to 1. I mean, that wouldn't be very nice having 1 raised to a power, because 1 raised to any power would just give us what? 1. All right. So let's look at an example. So this first example here, this is just kind of a review of evaluating numbers. Okay. So all we're going to do is we're going to take 3 halves. So we've got our functions f of x, g of x, and h of x, and they want us to find f of 3 halves. So I'm going to take the 3 halves, put it in the place of x. So that's going to be 4 raised to the 3 halves. Now, to simplify this, I'm going to need to convert it to radical form. So in a college algebra class, you would have learned this earlier in the course, like the first or second day probably. So just a quick review. So remember, when we change this from exponential form to radical form, that's going to be the square root of 4 cubed. All right. So if you remember, you have a property that says a to the m over n is equal to the nth root of a to the m, and a to the m over n is equal to the nth root of a to the m. Okay, these were the formulas here. Now, as far as this goes, you can use either one, but most of the time, okay, most of the time when you're converting from exponential to radical form, it's just easier to use this one up here. Okay, you can use this one, you'll get the same answer, but sometimes it makes it a lot more difficult, because these numbers, like if I put the 3 in this square root and I did 4 to the third, 4 raised to the third, I would get a big number, and then I would have to take the square root of it. But see here, the square root of 4, well, I know that's 2, okay, and then I have this power here, 3, and now I know 2 cubed is 8. All right, if I would have done it the other way, if I would have said, okay, this is the square root of 4 cubed, then that would have been what? The square root of 64. 4 to the third is 64, and then that would equal 8. You would get the same answer. And I know this really isn't that big, 4 to the third. That's really not that big of a deal, but sometimes these numbers can get a lot bigger than that. And like I said, it's just easier usually to do this one. All right, so now what about g to the third? So I'm going to take the 3, plug it in for x here. So that's going to be 5 to the 2 minus 3, which is 5 to the negative 1. Now, remember, in order to make your exponents positive, you can look at this as being over 1. And if you move a term across the fraction bar, it changes the sign of the exponent. So if I move this 5 to the negative 1 down below, that's going to be 5 to the positive 1. It changes the sign of the exponent. So this would be 1/5, and there's your answer. Now what about this, h of negative 2? So I'm going to plug the negative 2 in for x. So that's going to be 1/3 to the negative 2. All right, so also earlier in the course, you had a formula that said a over b to the n, or we can put negative in, it doesn't matter. A over b to the negative n is equal to b over a to the n. So if you have a fraction raised to an exponent, if you take the reciprocal of the fraction, see, all I did is I just flipped it. It changes the sign of the exponent. So this, if I take the reciprocal of 1/3, that's 3. And then I change the sign of the exponent, so that would be +2, and that would just give me 9. All right. So that's just a quick review on how to evaluate functions. Okay. All right. So now let's look at this. We've got the domain of an exponential function. So the domain, remember the domain, that's what all x values can I plug in. Okay, that's what the domain is. The domain, that's the x values that you plug in. The range, that's the y values that you get out. All right. So the domain of an exponential function, f of x equals a to the x, where a is positive and not equal to 1, is the set of all real numbers. So in other words, the set of all real numbers, so the domain of an exponential function, that would be -infinity to +infinity. Okay, that's all that means, because we can plug any number we want into x. All right, so now let's look at graphing some of these. All right, so sketch the graph and state the domain and range. All right, so to graph these things, what we're going to do is we're going to make up a table. Okay, we're going to use a table of values. Now, we know that the domain of an exponential function, that's -infinity to +infinity, we can plug in any numbers we want in for x. We can plug in whatever we want. But if you will choose your numbers a certain way, it just makes it easier. Now, what I'm fixing to do, the way that I'm going to choose my x values, you don't have to choose your x values like this. To me, this is just the easiest way to choose them. All right, so let's make a table. So I've got x, I've got f of x, and you want to pick about 5 points. So 0 is going to be the first one. I always want to have an exponent of 0. Okay, and then I'm going to choose 1, 2, -1, -2. All right, but like I said, you can choose any numbers you want, but it helps if you have some positive numbers and if you have some negative numbers for your exponents. What that's going to do is that's going to give you a better idea of what the shape of the graph looks like. Okay, so the thing that I go by when I'm choosing my x values for an exponential function, I always pick to where I'm going to have an exponent of 0, and then I'm going to have 2 positive exponents, that's where the 1 and 2 come in, and then 2 negative exponents, that's where the -1 and -2 come in. Now, and look, if you wanted to, you could choose 1 and you could choose 5. But just think about it. What's 2 to the 5th? That's 32. So then you would have to plot the point to 32. You see, the numbers can get big really quick. Okay? So just, you want to try to choose the smallest numbers you can. All right? So to get this, well, let's see, we've got f of 0 equals 2 to the 0. So I just take each one of these x values and plug them in for x. Now, anything raised to the 0 power is 1. Okay, so that gives me the point 0, 1. And then I've got f of 1, which is 2 to the 1st, which equals 2. And then I've got f of 2, which is 2 squared, which equals 4. And then I've got f of -1, which is 2 to the -1. And remember, we did this with a negative exponent. Remember, we did that right here. Okay, we did that. Got to move it down to the denominator. And so this is going to be 1/2. And then I've got f of negative 2, which is 2 to the negative 2, which is 1 over 2 squared. Move it, see, that's over 1, move it down, and that equals 1/4. And so this is 1/4. All right, so now we have our points to plot. Okay, so let's plot our points, and then we can draw our graph. All right, so I've got 1, 2, 3, 4. 1, 2, 3, 4. And look, I know that I'm doing this, and it's these marks that I'm making, they're not equally spaced, so it's not going to look as good as it could. If you want your graphs to look better, you can use graph paper. If you don't want to go out and buy graph paper, just Google graph paper and you can print it out. So let's plot the points. We got the point 0, 1, 1, 2, 2, 4. Then we've got negative 1, 1/2, negative 2, 1/4. And you can see the points we have here, how we can see what the shape of this graph looks like. So this graph is going to look something like this. Okay? Now, the one thing that you've got to make sure of when you're drawing this graph, you cannot draw it like this. This graph will never cross the x-axis. It just gets real close to it. So if you draw this graph and you draw it crossing this x-axis, it's wrong, okay? Because it's never gonna cross it. I mean, try to think of a number you can plug in for x so that you get a negative answer. There's not one, okay? All right, so now we've got to state the domain. So the domain, well, of course, we just saw that up here. See, the domain of an exponential function, negative infinity to positive infinity. And then we need the range. So the range, that's all the y values that it's going to hit. So what's the lowest y value? See, the y value is from here up. See how it's going up? So it's going from 0 to infinity. Now, is it ever going to hit 0? Will this graph ever touch the x-axis? No, it just gets real close. It gets real close to the x-axis. So we put a parenthesis on the 0, so that means we don't include the 0. Okay? All right, so here we have another one. Let's look at this. F of x equals 1/2 to the x. So once again, let's make a table. So I've got x, I've got f of x, and I've got 0, 1, 2, negative 1, negative 2. Pick my points, my x values. Okay, this is what I'm going to choose every time. Okay, every time. All right. So I've got f of 0 is 1/2 to the 0, which equals 1. Anything raised to the 0 is 1. F of 1 is 1/2 to the first, which is 1/2. I'll change those to being white instead of gray. And so f of 2 is 1/2 squared, which is 1/4. And then we've got f of negative 1, which is 1/2 to the negative 1. So remember, this is negative. We worked one of these earlier. You just take the reciprocal of the fraction, and that changes the sign of the exponent. So that's 2. And then we've got f of negative 2, which is 1/2 to the negative 2, which is 2 squared, which equals 4. So we've got 1, 1/2, 1/4, 2, and 4. All right, so now let's plot our points. So we've got 0, 1. 1 1/2, 2 1/4, -1 2, -2 4. And so this is our graph without that little piece, but it just kind of, all right, so there's your graph. So the domain, well, that's what, -infinity to +infinity. And the range, well, you can see the lowest value is almost to 0, and then it just goes up to infinity. Okay, remember the range is the y values. So that's 0 to infinity. All right, so what about this one? All right, so let's make a table again. So we've got x, g of x. So let's do 0, 1, 2, -1, -2. All right, so I've got g of 0 is 3 to the -0, which is just 3 to the 0, which equals 1. G of 1 is 3 to the -1, which that's going to be what, 1/3. G of 2 is 3 to the -2, which is 1/3 squared, which is 1/9. And this squared here is on the 3. Let me write that a little better. Okay. And then we've got g of -1, which is 3 to the -1, which is 3 to the 1st, which equals 3. And then g of -2 is 3 to the -2, which is 3 squared, which equals 9. So we've got 1 1/3, 1/9, 3, and 9. All right. So you can see what I'm talking about. See, I use small numbers, but look how quickly that y value goes up. Okay, and we just changed the base to 3 instead of 2. Can you imagine if this is a 4, a 5, or a 6? All right, so let's see what we've got here. So I've got 1, 2, 3, 4, 1, 2, 3, 4, and then 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so we've got 0, 1. We've got 1 1/3, which we'll say is about right there. 2 1/9, which is about right there. -1 3, and -2 9. So you can see this one is, see how fast these things grow. I mean, it gets big quickly. All right, so now we've got the domain. Well, that's -infinity to +infinity. And then once again, the range, you see that's from what, 0 to infinity. And it's important that you have a parenthesis on this 0 because that 0 is not included. Okay. All right, so we're gonna get back to graphing some more in just a minute. But let's look at this. We've got properties of exponential functions. So the exponential function f of x equals a to the x has the following properties. The function f is increasing when a is positive and decreasing when a is between 0 and 1. Okay, so when a is positive, okay, so remember they're talking about this value here, a. See how that's positive? Look at this thing. If we read it from left to right, see how it's increasing? And then what did it say? If a is between 0 and 1, so if a is a fraction or decimal, it's what? Decreasing. So if we read this from left to right, see how this is decreasing? That's what that means. And then the y-intercept of the graph f is 0, 1. And you saw that. You see how the y-intercept on all of these right there? That's the point 0, 1. And then look at this. There's your y-intercept, 0, 1. There's your y-intercept, 0, 1. Okay. The graph has the x-axis as a horizontal asymptote. So what that means, horizontal asymptote, that's a horizontal line that the graph is not going to cross. And you can see this right here, the x-axis, that's your horizontal asymptote. It gets close to it, but it's never going to touch it or cross it. And that was the case in all three graphs. The domain of f is negative infinity to infinity, which we saw that a while ago, and the range of f is 0 to infinity. So if you notice in the previous examples, that in the examples we just graphed, that was our range, 0 to infinity. Okay. All right, and then we have the function f is 1 to 1. So you talked about 1 to 1 functions when you did the section on inverse functions. Remember, in order for a function to have an inverse, it had to be 1 to 1. And remember, the way that you can check that if you have the graph is it has to pass the horizontal line test. So remember, if you draw a horizontal line through a graph and it intersects that graph in only one point, then that means it's 1 to 1. And so that's what that means. All right, so here, let's graph these. Now, you can do this by shifting, okay? Moving it left, right, up, down, and all that stuff. But what I like to do with these, I like to just go ahead and let's just pick points and plot them. To me, I think that's easier to do, okay? So let's do that. Let's make a table. So I've got x, y. All right. So I'm going to choose my x values just like before. So I've got 3, 4, 5, 2, 1. All right. All right, so you might be wondering, why'd you pick those points? You said earlier you picked 0, 1, 2, negative 1, negative 2. Okay, and that is correct. That's right. But just bear with me for a second. Just watch this. Okay, and actually, if you go back in the video, I didn't say I want to pick 0, 1, 2, negative 1, negative 2. I said I want my exponents to be 0, 1, 2, negative 1, negative 2. So that might give you a hint now as to why I chose those. Let's go ahead and evaluate and see. So that's y of 3 is equal to 2 to the 3 minus 3, which is 2 to the 0, which equals 1. Y of 4 is 2 to the 4 minus 3, which equals 2 to the first, which is 2. Y of 5 is 2 to the 5 minus 3, which equals 2 squared, which is 4. Y of 2 is 2 to the 2 minus 3, which is 2 to the negative 1, which equals 1/2. And y of 1 is 2 to the 1 minus 3, which equals 2 to the negative 2, which is 1 over 2 squared, which equals 1/4. And so I get 1, 2, 4, 1/2, and 1/4. All right. So do you see it? Remember, I want my exponents to be 0, 1, 2, negative 1, and negative 2. And there it is. Okay. So sometimes, depending on what your exponent is, sometimes you may have to choose your x values. You may not be able to choose 0, 1, 2, negative 1, negative 2. You choose your x values so that your exponents come out to be 0, 1, 2, negative 1, negative 2. Okay, I hope that makes sense. So now we can go ahead and sketch it. 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4. All right, so we've got 3, 1, 4, 2, 5, 4. We've got 2, 1/2, and 1, 1/4. And this is your graph right there. Now, if you look at this, if we graph just 2 to the x, that would be this point. Wait a minute. Let's see. Yeah, I did that. That would be this, and then we would have this, and then this. That would be 2 to the x. Okay, so all this is doing, this minus 3, is what it's doing. If you've got 2 to the x graphed, you're just shifting each of the points over to the right. Remember, it's moving to the right 3 units. That's all it's doing. But I mean, you would have to graph 2 to the x and then shift it. I think it's just as easy to do the table here and graph it. Okay. All right, so let's look at this one. All right, so let's make our table. So I've got x, f of x, and I'm going to choose what? -2. That's going to give me the 0. -3. No, sorry. Let's do this first. Let's do -1, 0, -3, -4. All right, so let's evaluate. So f of 4 is -4 plus 3 to the -2 plus 2, which is -4 plus 3 to the 0, which is -4 plus plus 1, which equals -3. Okay, so that's -3. And then I've got f of -1, which is -4 plus 3 to the -1 plus 2, which is -4 plus, what is that, 3 to the first, which is -4 plus 3, which equals -1. Okay, and so on. So if we plug the 0 in, that's going to be what? -4 plus 9. Yeah, -4 plus 9, which would be 5. All right. Now, I'm not going to plug them all in, but I did those so you can see, and I'm going to have to erase that so I can draw the graph anyway. And then let's just go ahead and plug the -3 in. So f of -3 is -4 plus 3 to the -3 plus 2, which that's going to be -3 plus 2. That's going to be 3 to the -1, which is -4 plus 1/3. Okay, so now we've got a fraction here, so that's going to be -4 plus 1/3, and that is going to give us -11/3. So you can see sometimes these things can get kind of confusing, or not confusing, but a little more difficult. And then this last one, when we plug the -4 in, this is going to actually come out to be -4 plus 1/9. And that is going to give us -35/9. Okay. All right. So we got all that plugged in. And let's see, 35/9. -35/9 is -3.89. Okay. Well, let's go ahead and let's draw this. So I've got 1, 2, 3, 4, 5, and then I've got 1, 2, 3, 4, 1, 2, 3, 4, and I've got 1, 2, 3, 4. All right. Now, it might help to kind of put what these are in decimal so you can kind of see. This is -3.89. 11 divided by 3, that's -3.67. Okay, kind of give us an idea where to put these. So let's plot the point -2, -3, -2, and then I've got 1, 2, 3. Whoop. And so -2, -3, and then I've got -1, negative 1. And then I've got 0, 5. That's up here. And then I've got negative 3. So 1, 2, 3. And then this is negative 3.67. So that's going to be about right in here. And then I've got negative 4. And then that's what? Negative 3.89. All right. Now look at this. You see this minus 4 here? This right here, let's dot this line in at negative 4. Okay. And I could probably draw these a little closer. Let's come down here and then maybe about right there. And let's go ahead and just sketch this in. All right, and it's going to come this way. All right, so what's happening here is, if you think about it, pretend like the negative 4 is not even there, and we just have 3 to the x plus 2, okay? So what that graph is going to look like is it would look something like this, right? You agree with that? Something like that, okay? 3 raised to the x plus 2. And this horizontal asymptote here is the x-axis, okay? This right here would be the line y equal 0. But what is this negative 4 actually doing? It's shifting this line down. You see that? It's shifting the line down 4 units. So y equals negative 4 becomes our horizontal asymptote. So if we have 3 to the x plus 2, well, if you look at that, all it's doing is shifting this down 4 units. And so that means it would be shifting down this horizontal asymptote 4 units. Okay? And so, and you can see, you can plug in like negative 5, negative 6, negative 7, negative 10, whatever. You're never going to get a value on this side of the negative 4. Okay? You'll never get a value on that side of the negative 4. All right? So now let's go ahead and state the domain. Well, of course, that's what? Negative infinity to positive infinity. The range, that's the y values. So we can see that's going from what? Negative 4 to infinity. All right? All right, so I hope all this is making sense. All right, so let's look at this one. All right, so let's do the same thing. So let's make an XY table. All right, so we've got what? 0, 1, 2, negative 1, negative 2. Okay, our exponent is 0. All right, so I've got f of 0. Let's do that in that gray color again. So f of 0 is negative 1/2 times 3 to the negative 0, which that is negative 1/2 times 1, which is negative 1/2. Okay, 3 to the 0 is 1. And then we've got f of 1, which is negative 1/2 times 3 to the negative 1, which is negative 1/2 times 1/3. Move that down, which is going to be 1/6. And then we've got f of 2, which is negative 1/2 times 3 to the negative 2, which is negative 1/2 times 1 over 3 squared, which is 1/2 times 1/9, which is 1 over 18. And then we've got f of negative 1, which is negative 1/2 times 3 to the negative 1, which is going to be negative 1/2 times 3 to the first, which that's just going to be negative 3/2. And then we've got f of negative 2, which is negative 1/2 times 3 to the negative negative 2, which is negative 1/2 times 3 squared, which is negative 1/2 times 9, which is negative 9/2. All right, so we get negative 1/2, we get 1/6, we get 1/18, we get negative 3/2. And wait a minute. Yes, I messed that up. That's negative, that's negative. Negative, negative. And then we get negative 9/2. All right. All right, so let's erase all this so we can have room. All right, so now let's take a look at what this graph is going to look like. All right, so let's see, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So let's plot our point. We got 0, negative 1/2. We've got 1, negative 1/6. So that'll be about right in there. And then we've got 2, negative 1/18. That'll be even closer. So, I mean, you can see some of these, it can be, just doesn't look very good when you draw them. But then we got negative 1/2, negative 1.5. Remember, this is 1.5 in decimal. And negative 9/2, that's negative 4.5, right? So that's going to be this, and that's going to be, let's see, 1, 2, 3, 4.5, and that's at negative 2, so about right in there. So this graph is going to look something like this, and it's going to get closer and closer. And so that graph looks something like that. All right. All right, so the domain, well, of course, that's negative infinity to positive infinity. And now the range. So the range is a little bit different on this. Remember, the range, that's the y values that it's going to hit. So you can see it's going from here down. So the range is going to be negative infinity all the way up to 0, but the 0 is not included. Okay, so you can see these things really aren't that bad to graph. Okay, but some of them can get messy. Okay, some of them can get messy, but notice in all of these, I chose my x values to be what? Not my x values. I chose to where my exponents would come out to be 0, 1, 2, negative 1, negative 2 every time. You don't have to do that. I just think that's the easiest thing to do. All right, so what about this one-to-one property of exponential functions? So for a positive and not equal to 1, if a raised to the x of 1 equals a to the x of 2, then x1 equals x2. All right, so what this is doing is this is showing us how to solve an exponential equation. All right, so in order to solve an exponential equation, you want the bases the same. And when the bases are the same, then you just set the exponents equal to each other and solve. Okay? All right, so let's solve these. So I've got 3 to the x equals 27. So I want to get the bases the same. So this would be what? 3 to the x. Now, 27, can I rewrite that as 3 raised to a power? Of course I can. That's what? That's 3 cubed. And so now to solve this, well, set your exponents equal. And there's your answer. Okay. And what about this one? That's what? 4 to the x equals what? Well, this is 4 to the first power, and if I move it up to the numerator, what does it do? It changes the sign of the exponent. My bases are the same. Set my exponents equal to each other, and I get x equal negative 1. All right, so what about this one? Well, this is what? This is 1 over 10 to the x equals, and 100 is what? 10 squared. Okay, now my bases aren't the same, but they're getting there. Okay, see, I've got a 10 here, I've got a 10 here. So, well, let's see, 1/10 and 10, they're reciprocals of each other. So if I take the reciprocal of this, that's 10. That's going to change the sign of the exponent, right? When you take the reciprocal of a fraction, it changes the sign of the exponents. And that equals 10 squared. So now I can set the exponents equal to each other. So negative x equals, negative x equals 2. And then I can divide both sides by negative 1. So x equal negative 2. What about this one? Well, this is what? 2/3 to the x. Well, can I write 9/4? Can I simplify that? Well, yeah, that's what? 3/2 squared. Okay. Well, my bases, they're still not the same, but I do notice that they're reciprocals of each other. So I could write this as 2/3 to the x equals 2/3 to the what? Negative 2. When you take the reciprocal, changes the sign of the exponent. And yes, if you wanted to, you could have taken the reciprocal of this one and wrote this as 3/2 to the negative x equals 3/2 squared. Either way. But now we just set the exponents equal. So that's x equal negative 2. Okay, so what about this one? All right. So for this one, you can see we've got quite a bit going on here. And what are we going to do to get these bases the same? Well, what I might want to try is maybe I can write this as 2/3 to something, right? 2/3 to a power. Well, let's see. 9/4, that's what? That's 2/3 squared. Right? But then that's still raised to the x power, okay? I just wrote the 4/9 as 2/3 squared, and then that's raised to the x, times, and then I've got what? 2/3 cubed, but then that's still raised to the 1 minus x. See that? And that equals 2/3. So it looks like we're going to be able to get like bases, okay? We're going to be able to get the same base of 2/3. And so this is going to be 2/3 to the what? Now remember, you've got that property that says a to the m raised to the n is a to the m times n. You multiply the exponents. So that would be 2x times 2/3 to the 3 times 1 minus x equals 2/3. And so that's 2/3 to the 2x times 2/3, and all I'm doing from this step to this step is I'm going to distribute the 3 minus 3x, and that equals 2/3. All right, so we're not quite there yet, but we're getting there. So this, well, I can handle this. This is what 2/3 to the 2x plus 3 minus 3x equals 2/3. Remember your property, a to the m times a to the n is a to the m plus n. If you're multiplying, you have like bases, you add the exponents. So now I've got what? 2/3. Now I just combine like terms. That's 3 minus x equals 2/3. Now just set the exponents equal. Remember, this is the same thing as being raised to the what? To the first power. So I get 3 minus x equals 1. So I get negative x equals, what is that? Negative 2. So x equal 2. And that's your answer. Okay. So, that's all it is. It's not bad, but this one we had to do a little bit to get there. All right. So let's see what we've got now. So let f of x equal 5 to the 2 minus x. Find x such that f of x equals 125. So what they're telling us here is f of x is 125. So we're just going to replace this f of x with 125. So that's going to be 125 equals 5 to the 2 minus x. So now it's just solving an exponential equation. So 125, that is what? That's 5 cubed equals 5 to the 2 minus x. So now we can set the exponents equal to each other and solve. So subtract 2, that's going to be, see, if I subtract 2 to both sides, I get 1 equals negative x, divided by negative 1, and that's going to give me x is equal to negative 1. All right. All right, so compound interest formula. All right, so compound interest, it says if a principal P is invested for T years at an annual rate R compounded N times per year, then the amount A, or ending balance, is given by this formula here. A equals P times 1 plus R over N to the NT. Okay. All right, so the principal P, that's what P is. T represents the number of years. R is your annual rate of interest. And N is how many times is it compounded per year. Okay. So let's look at an example. We'll learn how to plug this in. So find the amount or future value when a principal of $20,000 is invested at 6% compounded daily for 3 years. All right, so you got your formula. What I would do, and if you've watched my videos when it's dealing with, and you've got formulas in there, you hopefully remember what I said. Anytime you have to use a formula, write it down. Write down the formula. Okay? If you write it down enough, you'll remember it. All right. So in this problem, we have what? We've got P is equal to 20,000. All right, that's P. We've got R is 6%, so that's 0.06. You write it as a decimal. It's for 3 years, so T is equal to 3. And compounded daily, so N is 365. Okay, that's the number of days in a year. Now, you may see, you may be in another textbook and they're working a certain kind of problem that's compounded daily, and they may tell you to use 360 for compounded daily. Sometimes they may do that. If they don't tell you how many days, use 365. Okay, so let's plug all of these into the formula. So I get A is equal to 20,000 times 1 plus R, which is 0.06, over N, which is 365, and that is raised to the N, which is 365 times T, which is 3. And all I did, I plugged the numbers into the formula. That's it. And so this would be $23,943.99. And when you're in a math class and you're working problems dealing with money, students ask all the time, how many decimal places do I round it? Well, if you're dealing with money, round it to 2 decimal places. Okay. All right. So the one thing I wanted to go over before we went to the next problem is, notice this says compounded daily. Okay. And for compounded daily, N is 365. Okay. So we can have compounded monthly. N would be what? 12 months in a year. Quarterly. N would be 4. Semi-annually, N would be 2. And annually, N would be 1. Okay, so you should, based on that, you should be able to work any problem that they give you with this compounded whatever. Okay, whichever one it is, that's what N is. Okay, the difference it would be, this number here is what N would be. If this were monthly, then this number would be 12. Quarterly, this number would be 4. Semi-annually, it would be 2. Annually, this would be 1. Okay. All right, now continuous compounding formula. So if a principal P is invested for T years at an annual rate R, compounded continuously, then the amount A, or ending balance, is given by A equals P times e to the RT. All right. So for this one, E is a number, okay? E is a number, kind of like pi. You know, pi is what? 3.1415, so on. E is the number 2.718281828, and it just keeps repeating like that. Okay, that's E. It's a special number. We assigned it a letter just like pi. Okay, that's all it is, and it's on your calculator. It's above the natural log symbol. Oh, there's the natural log button. There's a LN button on your calculator. It's right up above that one. All right, so for this one, let's find the amount when a principal of $5,600 is invested at a 6.25% annual rate, compounded continuously for 5 years and 9 months. All right. So let's look at this. So we've got what? We've got A is equal to P e to the RT. All right. And so we know that P is equal to 5,600. Then we need R. R is 6.25. So remember, 6.25% is the same thing as 6.25%, right? Okay. And then if we convert that to decimal, that's 0.0625. So there's R in decimal. And then T, that's the years. That's what? 5 years and 9 months. Okay. So 5 years. So that's the 5 years. And then the 9 months. Well, what about the 9 months? Well, that's what? We got to put it in years. T is the number of years. So 9 months, that would be 9 over 12 years, which is 3/4, which that's 0.75. So that is 5.75 would be T. And then we plug this in, so that would be A equals P, which is 5,600, times E raised to the R, which is 0.0625, times T, which is 5.75. And then you punch that into your calculator and you get $8,021.63. And there's your answer. All right, this is the last one. I bet you're glad. Okay. All right. But just think how much smarter you're going to be after this video. All right. So it says the radioactive decay model. It says the mathematical model of radioactive decay is based on the formula A equals A0 times e to the RT, which gives the amount A of a radioactive substance remaining after T years, where A0 is the initial amount present and R is the annual rate of decay. All right. So as far as this section here goes, it doesn't get into a lot of detail about the radioactive decay and stuff like that. There's a section on applications, logarithmic and exponential applications, that gets into more detail where actually they give us information and we have to come up with what that is. In this section, they don't get as in depth because we need to learn how to do logarithms first. So we haven't learned logarithms yet in a college algebra course, but it's coming up. Okay, after this video, that's when we get into the logarithms. Okay, so as far as how they get their formula here, don't worry about it. And actually, when I wrote this problem, I didn't want to write the whole thing. I was getting tired of writing all this up by the time I got to this last example. So I'm gonna read the first part of the problem to you, and then we'll look here, and then we'll go down to this. But the problem says, finely chipped spear points shaped by nomadic hunters in the Ice Age were found at the scene of a large kill in Lubbock, Texas. From the amount of decay of carbon-14 in the bone fragments of the giant bison, scientists determined that the kill took place about 9,833 years ago. Carbon-14 is a radioactive substance that is absorbed by an organism while it is alive but begins to decay upon the death of the organism. The number of grams of carbon-14 remaining in a fragment of charred bone from the giant bison after T years is given by the formula, this, okay, where R is negative 1.21 times 10 to the negative 4. We recognize that number, don't we? That's scientific notation. Find the amount present initially and after 9,833 years. Okay. Now, what I would like to do is let's write this formula with R in there. Okay. So they tell us that R is negative 1.21 times 10 to the negative 4. Now, let's just go ahead and write that out as a decimal so we don't have to fool with the scientific notation. So remember, the negative 1.21 times 10 to the negative 4, I'm going to move it, 1, 2, 3, 4 places, so I need to add zeros here. Of course, that negative will come out there. So R is negative 0.000121. So that's R. We just converted it from scientific notation to standard form. That's all we did. They're the same number. Okay, I just think it's easier to punch this into a calculator than it is the scientific notation. Okay, all right. So that's going to give us A is equal to 3.6 e to the negative 0.000121 t. So all I did is I took this number and I plugged it in for R. That's all I did. Okay, so that's my function. Okay, and this is a decay. Okay, this is a decay problem. R is negative. Now there's going to be some problems that later on, okay, there'll be some problems where this number's positive. That's a growth problem. You got growth and decay. If it's a growth, R is going to be positive. If it's a decay, R will be negative. Now, let's get to what they're asking us. Find the amount present initially. So the amount present initially, well, they told us, I mean, it's right here. A0 is the initial amount present. That's just that number in front of E. That's the number initially. So we can see that would be 3.6 grams. Okay, but let me show you how that works. Basically, the amount present initially, that's the amount present at time t equals 0. That's when t is equal to 0. Remember, t is the number of years. So A of 0 is equal to 3.6 e to the negative 0.000121 times 0. Well, this is what? This is e raised to the 0. Anything raised to the 0 power is 1, and 1 times 3.6 is 3.6, and that is grams. And so that's the amount present initially. This right here is answering that part of the question. And then they ask us how much is present after 9,833 years. Okay, so that's T. So A of 9,833, that is going to be 3.6 times e to the negative 0.000121. So 0 times 9833. You'll punch that into your calculator, and that is 1.1 grams. And so there's that answer. All right. So I hope you had fun in this video. It wasn't too bad. Okay. It's not that bad. Just remember on the graphing, what do you want your exponents to be? 0, 1, 2, -1, -2. Okay. You know how to solve the equations, get the basis the same, set the exponents equal to each other. Now you might have been wondering through the whole video, well, what if I can't get the basis the same? That's later. Okay, we've got to learn logarithms first. All right. So I hope this helped. Check out my other videos. Give me a like, share, and subscribe. And thanks for watching.